Good afternoon, students. Today we will discuss the first chapter of class 10 mathematics. The name of the topic is real numbers. In this lesson, the subtopics to be discussed are idea of real numbers, process of division, Euclids division lemma, and finally Euclids division algorithm to find HCF of any two positive integers. So first of all, let us recollect what you learned in class 9. That is all about real numbers. What are real numbers? Dear students, real numbers are nothing. They are the rational numbers or irrational numbers. Rational numbers and irrational numbers together form the system of real numbers. Some of the examples are given here: 2, 1 by 2, 0.11, square root of 2, etc. So these are all real numbers. The first number 2, which is given as an example here, it is a rational number because it can be put in the form of p by q, where p and the q are integers and q is not 0. Similarly, 1 by 2, 0.11, they are also rational numbers. Therefore, they are real numbers. And again, square root of 2, it has non-terminating, non-recurring decimal representation. Therefore, it is irrational and we call them as real numbers. Then after this, let us go to the process of division. When we perform division, then we always need two numbers. Let us take the first number as 10, a equal to 10, and the second number as b, that is 3. So when 10 is divided by 3, then we perform like this. 3 3 are 9, the quotient is 9 here, and the remainder is 1. So in this division, what we have got is that a is known as dividend, b is known as divisor, that is 3, quotient is again 3 here, and remainder is 1. Then after this, let us remember what is a lemma. A lemma in mathematics is nothing. It is a mathematical proven statement which is used to prove other statements. We sometimes need some mathematical statement which has already proof, and it can be used to prove other statements. So such type of mathematical statements are known as lemmas. So in class 10, one of the most important lemma is Euclids division lemma. Euclids division lemma is nothing in one sense. It is related with the operation division, and the relation dividend is equal to divisor into quotient plus remainder. Given positive integers a and b, there exist unique integers q and r such that a can be expressed as bq plus r. And here a is nothing, it is our dividend, and b is our divisor, and r is our quotient, q is our quotient, and r is our remainder. Here the condition r should satisfy is 0 is less than or equal to r, less than b. So let us rewrite the division which we have taken earlier. For example, when a is divided by b, where a is 10 and b is 3, so we can express 10 as 3 into 3 plus 1. 3 3 are 9, 9 plus 1 is equal to 10. and here our remainder is 1. So it means that it satisfies the condition 0 less than equal to r less than b. So r lies between 0 and 3. Next, what is an algorithm? An algorithm is nothing, it is a series of well-defined steps which gives a procedure for solving a type of problem. Whenever we solve a problem, it must be solved under some well-defined steps. So this step-by-step procedure for solving a problem is known as algorithm. And in our first chapter of class 10 mathematics, here is again a very important algorithm, that is Euclids division algorithm. We have to use this algorithm for finding ICF of any two numbers. So Euclids division algorithm is nothing, it is the step-by-step procedure for finding the ICF of two numbers using Euclids division lemma, that is A is equal to BQ plus R. Now let us apply Euclids division algorithm to find the ICF of two numbers. Yes, let us find the ICF of 225 and 350. Here in this algorithm, one thing we have to remember is that we have to find the ICF, and the lemma is to be applied continuously till the remainder is 0. So when the last remainder becomes 0, at that time we will find the divisor. That last divisor which we use is known as ICF of the two numbers. So let us see how we can find the ICF of 225 and 350 with the help of Euclids division algorithm. Yes, using Euclids division algorithm we get 225. Yes, 350 is to be divided by 225, so we have to multiply it by 1. Otherwise, if we think of the second number 2, then it becomes 450. 225 multiplied by 2 means 450. So we cannot go with 2, so we have to multiply it with 1. So here the remainder becomes 125. So here we cannot proceed the division further because there is no more digit we have to take down for the division. So in such a situation, in Euclid's division algorithm, we have to carry forward the previous divisor as the new dividend, and the remainder which we have got should be considered as the divisor. So we have to make the relation among these four numbers. So 350 can be written as 225 into 1 plus 125. And in the next step we have to go for the second division, that is 125 should be considered as the divisor, and the previous divisor, that is 225, will become the new dividend. In the second step we have to multiply with 1 again, and here we observe that the remainder is 100. So these four numbers 125, quotient 1, and the remainder 100, and dividend 225 can be written like this again. 225 is equal to 125 into 1 plus 100. Like this we have to carry on till the last remainder is 0. Again 100 will become what? 100 will become the new divisor. And 125 will become what? 125 will become new dividend. Like this we have to carry on. Okay, and here again we observe that 25 is the remainder. So in the step number 3, we will express 125 again as 100 into 1 plus 25, and finally the last, there is 25 should divide to 100, and here we observe that 24 are 100, and in step number 4 we observe that 100 is equal to 25 into 4 plus 0. So here the last remainder becomes 0, so we have to stop here, and the last divisor, what is the last divisor here? The last divisor is nothing, it is this 25. So this 25 becomes the ICF of the two numbers 350 and 225. So this process of finding the ICF is known as Euclids division algorithm using Euclids division lemma. Here the last divisor is 25, therefore we can say that 25 is the ICF of 350 and 225. Thank you all. See you again in my next lesson. Thank you once again.